Hello and welcome once again to an INB382 demo in Unity, and this one in particular is the alpha blending utility, Unity demo. So if we have a look in our scene here, I've got a teapot. Why have I got a teapot? Well, there's a number of reasons. First of all, you need to understand the history of computer graphics to know that the University of Utah teapot is very important as a demo device. Secondly, it's also very useful for showing off alpha blending and some of the vagaries of alpha blending. But anyway, let's move on. So first of all, you'll understand if we go over and look in this shader here, we can see that our object has been given an alpha blending value and that it looks transparent. It's a simple form of non-refractive transparency as we cover in the lecture. One of the important points to note is that we can change this transparency using an alpha value. So this alpha value over here is set to about 0.1 or 0.3. If I set it to 0, funny enough, it's gone. Why? Because the alpha channel controls the contribution of each color to the pixels in the frame buffer. So this moment it's saying the teapot is contributing nothing. Here it will contribute 0.1 of its color. 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and you can guess when it's 1, the teapot is solid. So this is all fine and dandy, and it enables us to control what contribution each object will make to the final pixel color in the frame buffer. So going to the actual shaders and scripts. So here's our script, and again we've got a value, we saw it before, exposed in the properties section of the shader, and we have an alpha value here that we manipulate as per usual with our renderer.materialSetFloat function. All very good. Going to the actual shader that implements it, we see up here the properties, there's an alpha value that comes in, it's just a float. We set it to 1 by default. Here is its replication, just to reinforce this idea of data flow with shaders. And we implement here in our vertex shader just a simple diffuse and ambient lighting model, very similar to the simple lighting model, that demo that you'll see in the lecture resources. So that's fairly straightforward. I'm not going to concentrate on that. You should be starting to get familiar with the contents here and the transforms and the use of the camera, position of world, and so forth. Moving right down to where the magic happens is in the pixel shader, because we're dealing with the final color and its contribution to the frame buffer. So you note that you've probably been playing with colors, and some of you are familiar, of course, with the use of alpha blending, maybe even by using Photoshop. But the idea here is that each color is a float 4. So remember, the pixel shader puts out a color. There's the color semantic. And the idea is that the first 3 components are the red, green, and blue, RGB, as we see it here. So this is just a pass-through shader, except that it does do one thing. So I guess it's not quite pass-through. It modulates the alpha value. So it ignores the alpha value generated via the coloration of the pixel, and it enforces its own alpha value. So as you see before, that's the parameter I was varying before to make the object more or less invisible. So this is how you implement, just in the shader component, that alpha blending. It's just an explicit parameter for the A component of a color. Of course, that can be implicit, because of course when you have texture values and you have visibility on your textures, which I get to, you can actually set the alpha value so you can blend in various bits of textures. So that can actually be sourced from the color if you wish, but in this case we're controlling explicitly because we just want to do that for this demonstration. Now the other aspect of how this is manipulated, and one way of doing it, is by using the shader lab components here. So there's a blend command, and you'll see that after that you specify what amount of the source pixel, the pixel coming out of the shader, and what amount of the destination pixel, which is actually what's in the frame buffer at this moment in time. I cover the theory on this in the lecture notes, but suffice to say that you can see that if the source alpha is, say, 0.1, that means I want 1/10 of my teapot to blend into the frame buffer, then that means we're going to get 9/10 of the frame buffer's colour. This is how you get this mixing and this see-through effect. So 0.1 and then the complement of the background colour, 0.9. So as I increase source alpha from 0 to 1, I'm going to get less and less of the background. And this is how the blending is accomplished according to a blending equation via the underlying graphics library, which you see in the lecture notes. So this is typically how you use it. There are other ways of doing blending, but I don't cover them so much, just so you're aware of the concept. And source and 1 minus source as the two components is a common way of blending things, blending your pixels into the frame buffer. Moving right back to the Unity environment, I want to show you an anomaly that occurs with this blending. There's a problem with blending. Blending has an issue with the ordering of the rendering. So we can see it here when I make the alpha value less than 1. And what we see here, especially if I go back to this scene here so I can show it up, note the back faces, or some of the faces on the rear side of the teapot are not really functioning properly. It looks odd, they're poking through. You get this sort of solid ring from the back part of the teapot appearing. Now the reason this is occurring is because really what you want to do is always render and blend from the back of the teapot forwards. So that the front part, which in this case is the bottom, should appear later, or be after the rendering of the back parts. But the problem is the teapot is not drawn in the correct Z order with respect to the camera. And this means that when you blend in, you get these artifacts occurring. So this means that this sort of simple form of blending requires a bit more subtlety and nuance in order to make it work. And typically, that means that you have to sort your polygons and render them in the correct order of visibility from the camera's position. Then you will get a correct blending. These are out of order. The back has been drawn after the front. So that means when it's blended in, it appears more solid and everything looks a bit icky. So this is a common problem. We don't solve it in the unit. There are advanced techniques and other methods using BSP trees and all sorts of Z buffer occlusion methods. But just so you're aware that you get these effects if you just blend in a naive fashion. And you need to be aware of that in your game if you want to avoid these artifacts. Okay, thank you very much.